All right, welcome to 7.03. We're going to start learning how to use technology to help us estimate areas under a normal curve. And hopefully by now we understand that doing some of these calculations like standard deviation and the area underneath, within one standard deviation in an approximately normal distribution can be kind of tedious. And so using a normal curve, we want to have a way to find the amount of the distribution, which is, maybe within one standard deviation or, within two standard deviations, or we could get more complicated and try some more sophisticated situations. And so we want to have a way to discover these areas under the curve without doing it by hand. And so we're going to start using technology more heavily. So let's go ahead and take a look at a question which will help drive some of this new discovery. Suppose you took a math test and a Spanish test. The mean score for both tests was an 80, and you got an 86 on Spanish and a 90 on math. So it might seem, right off the bat that, oh, I did much better, on the math test than I did on the Spanish test. But once you think about it a little more deeply, the question comes up: did you necessarily do better on the math test relative to the other students? So I want you to think about a way in which this could be the case, that you actually didn't do better on the math test relative to the other students, and think about what that means. And I'll give you one hint, and that is to think back about standard deviation and how this could play a role in understanding how well you did relative to the other students. Okay, so consider this. Imagine that on the math test, and we're working with normal distributions here, so we're using the normal curve to approximate it. And there's a chance that you got some sort of skewed distribution and you couldn't use this, but for now we're going to pretend this was a normal distribution. And let's say for the math test, the standard deviation was 8, and for the Spanish test, the standard deviation was 4. So now you might have a different idea of what your score means relative to your classmates, right? So for math, that means that on average, right, on average, everyone was about 8 points different from the mean, right? So it was much more spread out, right? And on Spanish, the average was that you were 4 points off from the mean. And so if you think about your Spanish test, right, how many standard deviations was your score away from the mean, right? How many standard deviations above the mean was your score? And so you could think about it, well, you were at, an 86. And if a standard deviation is 4 away, how many standard deviations were you? And you could think about the same for math, right? If you got a 90, how many standard deviations away were you from the mean if the standard deviation was 8? And so I want you to pause the video and try and think about how it is that you could compute these values. So let's think about it. If for math, let's do math first. Let's say you got a 90, right? So a 90 is that more or less than one standard deviation? Well, it's certainly more, right? One standard deviation was 8 away from the mean. It was an 88, and you got a 90. Right? So that is a little more than one standard deviation. How much more, right? Well, here's how we're going to compute it, right? If you got a 90, right, how far away was that from the mean? Well, 90 minus the mean, or 80, will tell you the distance away from the mean. And then to find out how many standard deviations that was, you just want to divide by the standard deviation. And so what I'm going to find is that, my math score was 10 units away from the mean, and a standard deviation is 8 units, 8 points. And so if I have something that's 10 and I'm measuring it in terms of something that's 8, 10 divided by 8 is going to be 1 and 1/4. 1 1/4 standard deviations away from the mean. So this is a way of talking about how much better did you do than everyone else. Well, on average, people were, 8 units away from the mean, and you were 1 1/4 standard deviations. You were 10 units better than the mean, and so you were 1 1/4 standard deviations above the mean. For Spanish, let's calculate that. You got an 86. The mean was 80. So you are 6 units better than the mean. And the standard deviation was 4. So how many standard deviations were you better than the mean? Well, 6 divided by 4. You were 1 2/4, or 1 1/2 standard deviations better than the mean. And so it wouldn't make sense for you to say that you did better on the math relative to the whole class because, actually on Spanish you were you were better than the whole class by a little bit more because you were 1 1/2 standard deviations better than the mean. And so there was, if you think about it, if you look at these curves here, right, this is much more spread out. The standard deviation is bigger on average. People were 8 units away from the mean, and on Spanish, people were much more closely clumped to 80. And so when you got an 86, it was actually more impressive because you were further ahead of the whole group. And this is what's called a z-score, right? How many standard deviations were you either above or below the mean? And so on the next slide, we're going to define what a z-score is, and this is going to help us to compute, how much data is below your particular score or above your particular score or in between two particular scores. And don't worry, we're going to use calculators to do this, but it's important to understand what a z-score means. A z-score, as we just talked about, for a particular value in a normal distribution, measures the number of standard deviations away from the mean that value is. And the way that we compute it, just as we did on the previous slide, is that we take the value we're interested in, we subtract the mean away from it. This will tell us the total distance it is away from the mean, and then we divide by the standard deviation to tell us just how many standard deviations were you away from the mean. And so you can think about it. If your value is greater than the mean, you're going to get a positive z-score. And if your value is less than the mean, then you're going to get a negative distance, right? And you're going to get a negative z-score. And that will tell you that, if you get a negative value, you're actually that many deviations below the mean. Whereas if you get a positive value, you're going to be that many deviations above the mean. Okay? And obviously a z-score of 1 tells you that you're exactly 1 standard deviation above the mean. And if you got a z-score of -1, then you're exactly 1 standard deviation below the mean. And so this is going to be a way for you to think about, how does your particular data point relate to the overall group of data points that we have in our distribution. So I'm just going to give you a couple of simple scenarios for you to check out and try. Then on Monday we will start talking about how to use technology to do this work for us. Here are a couple of questions for you to go ahead and give a try that ask you about z-scores. And a z-score is not complicated. It's very simple construct, so you just want to get some work with it. And in these situations, we're assuming that all these are normal distributions. So we are using a normal distribution to approximate this data, and so we can use a z-score to talk about and think about these particular values. So go ahead and write these out, try these on your own, and if you had a question or you're confused on one of them, make sure you include that. You make a comment on the video and go ahead and answer someone's question if you have the opportunity, and we will discuss these on Monday.